Hello guys, so in today's video I'm going to be talking about work, energy and power and work energy in theorem. So let's go into work first. So this work. First, what's the meaning of work? Work is just the product of force and the distance moved in the applied force. And what you should note about work is that work is work is force times displacement. This S this S is not distance, it is displacement because it is the distance moved in the direction of the applied force. That means the distance has a direction, and the direction is where the force is moving. So it is displacement, not ordinary distance. So you should also know that. And you should know work is a scalar quantity, of course. Work, energy, power, they are all scalar quantities. What you should also know is that when you are in vector product and scalar product, you use scalar product for work because it's a scalar quantity. So that we have F is equal to F dot S. You should know this thing in vector. So you should note this, that whenever you have to use vector or scalar product for work, you have to use scalar product because work is scalar quantity. You should know that force is vector quantity. Force is a vector quantity, and this S here is displacement, and also a vector quantity. And you can also remember in the last video about vector that when we have vector dot vector, it can be scalar and it can be vector. So this vector dot vector is scalar here. So work is a scalar quantity. You should also know that. So, and for scalar quantity, when we have work is equal to F dot S, that's force dot displacement. This can also be written as Fs cos theta. Fs Fs cos theta. Whereas can remember A dot B is equal to AB cos theta and A cross B is equal to AB sin theta. So F dot S can be Fs cos theta. You should know that this cos theta belongs to the force here. So it is writing F cos theta dot S. You can just leave it like this, Fs cos theta. So if you are asked to find the angle between the force and the displacement, this is the formula you use, and this is the angle between them. So if you ask to find the angle, you just use this. We are going to be solving questions now. So, but just note that if you are asked to find the angle, you use this formula to find the angle. So W is equal to Fs cos theta, W is equal to F dot S, and so on. So let's go into solving questions. So these are the questions I'm going to be solving. To get access to the question, the link is in the description below this video. So just download it. It's in a Google Drive. Just download it. Picture format in the Google Drive. So just download it from the link. It will be in the description of the below of this video. So let's check question 1 under work. So they said a body moves through a distance. It moves through a distance of 5I plus 2J minus 3K from the origin 000 under the influence of a constant force. Force is 4I plus 3J minus 2K. Then they say we should determine the work done. Determine the work done. B, determine the angle between F and S. So let's calculate A. They said we should find the work done. So to find the work done, we are just going to use W is equal to F dot S. W is equal to F dot S, and we just do the scalar product. F dot S. I know scalar product is just direct multiplication. So 5 times 4, that's 20. 20 I dot I, that's 1. So 20 plus 2J times 3J, that's plus 6. And minus 3 times minus 2, minus 3K times minus 2K, that's also plus 6. Because minus times minus is plus. So when you add all this together, we are going to get 32. So the work done is 32 joule. So they said you should also find the angle between F and S. Now this is when we are going to need this formula. Our work done is 32 joule. So they said you should find the angle between F and S. So that's when you are going to use this formula. W is equal to F S cos theta. So this is the angle they're asking us to find. So what do we do here? We already know W is 32 joule as we found from A. So that will be 32 is equal to, then we look for the magnitude of F, the magnitude of S. Let's just put the magnitude. You should know that this thing represents magnitude. When you see this two dash, it represents magnitude. So we are going to look for the magnitude of F, the magnitude of S, then we multiply it together, then cos theta. So how do we find the magnitude of F and S? I'm coming. Let me use the calculator. So to find the magnitude of F, what you just do is you take the square of each of these numbers, then you square root everything. So here we are going to have for F, that's square root of, you can say square root of 4 square plus 3 square plus 2 square. Why this is also plus? Because minus 2 square is also 4, because minus 2 times minus 2 is to give you plus 4. So that's why I just put plus here. No need. So when we do this for F, the magnitude of F will be, just take our calculator, 4 square plus 3 square plus 2 square. That will give you 5.39. That's 5.39 Newton. 5.39 Newton. Let's also find the magnitude of our S, which is displacement. That will be square root of 5 square plus 2 square plus 3 square plus 3 square. That will give you square root of 5 square plus 2 square plus 3 square. That will give you 6.16. 6.16 meter. So that's 5 point, then write it here. What we've got, 5.39 times 6.16 cos theta. So since we've gotten that, then we want to find theta, the angle between F and S. Angle between F and S. So to find the angle between F and S, we just divide this stuff, divide 32 divided by 5.39 and 6.16. Then we take the cos inverse. That will be cos of theta is equal to 32 over 5.39 times 6.16. 6.16. I hope you understand what I did here. I just divided by this stuff. This 5.39 times 6.16. I divided 32 by 5.39 times 6.16. Then I took the cos inverse of the value. Then we get our theta. So theta will now be equal to. So you can do this thing one by one if you are using your calculator. But if you are using like a calculator like this, you can just input it like very fast and give you the answer. That's cos inverse of 32 5.39 times 6.16. So answer we got 15.47 degree. That's 15.47 degree. So that's the answer. That's the angle between F and S. So that's how to solve questions like that. Yeah, so let's check another question just like that. So for you to get better in topics like this, you need to like solve a lot of questions. So let's solve this question number 2. So question number 2, it said a force of 6i 6i minus 2j in Newton acts on a particle that undergoes a displacement change in r which is 3i plus j in meter. This is j in meter. Then it says you should calculate the work done by the force on the particle. So to calculate the work done, we all know work done is f dot s, but in this situation is f dot change in r. It's still the same thing. Change in r is still displacement, s is still displacement. So to find that, you just have to do the dot product. So 6i times 3i, that's 18, minus 2i times plus j, that's minus 2, and that will give you 16 joule. So they now said in the question B now says find the angle between F and change in R. So just write your 16 joule one side. Write your 16 joule one side. Then we all know that to find the angle, we are going to use this formula. To find the angle between F and change in R, we use this formula. W is equal to F S cos theta. So this is the angle between the F and S or F and change in R. Still same thing. So what do we do? Let's just write it like this: cos inverse of W over magnitude of F and magnitude of S. So that will be cos inverse of our work. W is 16 joule. That's 16 over. Can you see the board? Yes. So let's find the magnitude of our F. The magnitude of our F will be the square root of 6 square plus 2 square. And that will give you what? Give you 36 plus 4. That's root 40. 6 square plus 2 square. I'll give you 6.32. 6.32 Newton. Then the magnitude of our change in R or S, that'll give you that square root of 3 square plus 1 square. That'll be 3 square plus 1 square. That'll be 3.16. That'll be 3.16 meter. So just input your value: 6.32 times 3.16. 3.16. So the angle between F and change here will then be, let's do that as 6.32 times 3. So that will be 36.76. 36.76 degrees. So that's the angle between them. So the angle between them will be 36.76. Before we move into energy, there's this formula you need to know about work when you need to integrate. So in stuff like this, in questions like that, don't use dot product, because it won't even work. And this is how you detect when to use the integration and when to use dot product. If they give you ordinary IJK, then use your dot product like that. But if they give you something like this, and they say, let's say the force is 2, they now put X I, and now say maybe 10 YJ. What this just tells you is that this force is moving in the X direction, while this one is moving in the Y direction. Now it's possible for the force to move in the X direction, and they are just asking us to find the work only in the X direction. So if they ask us to find the work only in the X direction, we just ignore the Y direction. We are just going to ignore it. So in this situation, do not use dot product. You have to use integration. This is how integration looks like. You have to use integration. So let's take a question on that. So after this question, we move into energy. So let's take a look. They said a force F of 4xi plus 3yg plus 3yg Newton. 3yg Newton. Then I said a force F 4xi plus 3yg acts on a object as the object moves in the x direction. That means the object moves in the x direction. So we will just be considering only the x component of the force. It moves in the x direction, right? From the origin, that's from x equal to 0 to x equal to 5.0 meter. That means it moved from x1 0 to x2 5.0 meter, right? And I say find the work done on the object by the force. If they ask us to find the work done, Now, this is how to solve questions like this. They said it moves in the x direction, right? And they gave us from origin, which is 0, to the final the final displacement. That's final distance. That's 5 meter. It was displaced by 5 meter. So the formula you have to use is f is equal to the integration of f dx. So this is the formula. So you're just going to integrate. You don't need to know this formula. Let me just teach you how to integrate. So let's say we have something like x squared. Let's say we have something like x squared, and they said you should integrate x squared. What you have to do is just add one number. Just add one to the exponent, and divide by all this. That will be 2 plus 1. So that will be x cube over 3. So that's how to integrate. So let's say we have another one. Let me give you another example. Let's say we have let's say we have 5x squared. 5x squared. And you say you should integrate 5x squared. What you just do is we add 1 to this exponent, and we divide by 2 plus 1. So all we are doing is we are just adding 1 to this exponent, and we are dividing by everything. So that will be 5x cubed over 3. Let's say they ask us to integrate, they ask us to integrate, they ask us to integrate x cube. What do? We just add plus 1. We add plus 1 here, then we divide by 3 plus 1. That will be x cubed over 3. X cubed over 3. So that's how to do it. Sorry, x raised to power 4. X raised to power 4 over 4. 3 plus 1 is 4, of course. So that's x raised to power 4 over 4. So that's how to integrate. So we are going to be using this principle. We are going to be using it to solve this question on work. So now they say you should integrate this. So what do? Since they're asking us for the x component, the object with the x component, just ignore the y. So that we are going to integrate 4x. We're going to integrate 4x. Because of course 4x that is here. When it moves from 5 meter to 0 meter. Now just watch closely how I'm going to integrate this. So the first thing you need to do, first integrate this 4x. So when you integrate this 4x, we have 4x here. How do we integrate 4x? You know there's an invisible one here, because x itself is x raised power 1. So what do we do here? We add, there's an invisible one here. So what do? We just add 1. We just add 1, and we also divide by 1 plus 1. That will be 4x squared over 2, and that will be 2x squared. That will be 2x squared. You can see that will be 2x squared. So we've gotten 2x squared. How do we now get our value for work? Because this is not our final answer. So we all know that we've gotten 2x squared. So let's just write it here. 2x squared. We've integrated it already, 2x squared. But they say it moves from 0 to 5 meter. So 5 will be on top here. Because if you want to impute value for integration, you just have to put the numbers here. This will be the initial, and this will be the final. So to plug in our value, we will do final minus initial. So what we are going to do now is we are going to impute 5 into this equation, minus impute 0 into this equation. So let me show you what I'm talking about. So we first impute 5. That will be 2 bracket 5 squared minus 2 bracket 0 squared. So 5 squared, that's 5 times 5, that was 25. 25 times 2 is 50. 50 minus 0 squared is 0. 0 times 2 is also 0. That's 0. And that will give us 50 joule. That will give us 50 joules. So that's how to solve questions like this. You integrate, make sure you understand integration. Also, I did some examples on integration. Just basic integration, not complex integration. In physics, it's just basic integration. Please don't go and know complex integrations just because you want to solve this part of physics. It's just basic integration you just need to know, and just know how to substitute your value. This is final, this is initial, so just final minus initial. Sometimes it might not be zero that will be here. They can give you from when x1 is 2, x2 is blah blah blah. Then just input it like that. It's not every time it is zero. So now let's imagine, let's say they ask us in the y direction. Now let's just do something. Let's say they ask us in the y direction. What we just need to do is we just integrate this 3y. Let me integrate 3y. Can you see the board? So let's say they asked us for the y direction, then they said y1 is 0, y2 is 5. We just integrate 3y. That will give us one, that's 1 plus 1 over 1 plus 1. That will give us 3y squared over 2. Then final minus initial. Then we just input our value. That will be 3 bracket 5 squared over 2, then minus 0, since everything is going to be 0. So let's just do that. That's 5 squared is 25. 25 times 3 divided by 2. That will be 37.5 joules. So let's say they asked us in the y direction now. We are going to get 37.5 joules, but they asked us in the x direction. So that's why we got 50 joules. So if they ask for the y direction, ignore x. If they ask for the x, if they say the object is moving in the x direction, you ignore y. If they say the object is moving in the y direction, you ignore x. So it's not every time you have to be using x. They can just twist the question.